Hi guys, so today we're going to take a look at question 4 of the 2017 exam paper 1. Okay, so the amount of a substance remaining in a solution reduces exponentially over time. An experiment measures the percentage of the substance remaining in the solution. The percentage is measured at the same time each day, and the data collected over the first 4 days are given in the table below. Based on the data in the table, estimate which is the first day on which the percentage of the substance in the solution will be less than 0.01%. Okay, so first of all, we should immediately look at the amount of the substance remaining in the solution reduces exponentially. And whenever you read something is reducing exponentially, we're looking at a geometric pattern. So a pattern in which the ratio of one term to the other is constant. So term 1 to term 2 is the same as term 2 to term 3. So we're looking at, so this means a geometric pattern. And we know that a geometric pattern is of the form Tn, so the nth term, is a times r to the n minus 1, where a is the starting term, or the term 1, and r is the common ratio. Okay, so our starting term, a, which is T1, our first term, is 95. And our ratio, r, so this is the Tn minus 1 over Tn. So, sorry, Tn plus 1 over Tn. So the value of a term over the previous term. So we could look at T2 over T1, or we could look at T3 over T2, or we could look at T4 over T3. But any of these are going to work because they're the same. So we'll just look at T2 over T1. So R equals the second term over the first, which is 42.75 over 95, which is 9 over 20. And just to show that, any of these would work, let's let R equal T3 over T2, and you can check this yourself. 19.2375 over 42.75, and this again equals 9 over 20. Okay, so our common term is 9 over 20. So we now have a formula for our pattern. Tn, the value of the nth term, is 95 by r, 9 over 20, to the power of n minus 1. Okay, and what is it we're looking for? We're looking for the first term such that Tn is less than 0.01. Okay, so how we're going to do this is, well, we're going to let our formula Tn equal 0.01, and then this will probably not give us a whole number. So maybe this will be 9.42. So after 9.42 days, the amount of the substance in the solution will be 0.01%. And so we'll have to round up to find the first day that it is less than 0.01. Okay, so let's let our function equal, or our term expression equal 0.01. So 95 by 9 over 20 to the power of n minus 1 equals 0.01. So 9 over 20 to the power of n minus 1 equals 0.01 over 95. Okay, and now most of your teachers will probably have you take the log of both sides to bring down this power. But I actually think that this comes from a bit of a lack of understanding of what logarithms are. So if we take a look at this equation, this is essentially asking, so our unknown is this term here, this n minus 1, this power. So there's this question that this equation is asking. 9 over 20 to the power of what our unknown is equal to 0.01 over 95. That's what this equation is asking us. And the logarithm is basically that question rephrased as this. So the logarithm works like this. So logarithm of base 920 and in the brackets 0.01 95 over 95. So this logarithm, this expression, this is this question in maths notation. That's what the logarithm is for. The logarithm is to answer, the logarithm exists to answer something to the power of what is equal to something. So for example, our natural log, log n, or log e of, let's say, 2, is the question e to the power of what equals 2. That's just what the logarithm, that's how the logarithm is defined. So instead of taking log of both sides of our equation here, we can just rewrite this as log base 9 over 20. Actually, since we've already written it down here, log base 9 over 20 in brackets 0.01 over 95 is equal to n minus 1, because the log is asking 9/20ths to the power of what is equal to 0.01 over 95. And so then if we just plug this logarithm into a calculator, we get 11.47. Okay, so that means that n equals 11.47 plus 1, n equals 12.47. So on the 12.47th day, the percentage of the substance in the solution is equal to 0.01%. So the first day that it's less than 0.01% is just the next day. It's just rounded up. So n equals 13 is the first day that the percentage of the substance in the solution is less than 0.01. Okay, and so I'm not trying to confuse you with this logarithm. I think that most of your teachers are just going to teach you this rule. Whenever you have an unknown in the power, so a to the n equals b. Whenever you have an unknown in the power, just take log of both sides and it'll work out. But I think that you can understand this. You know, and I think once you understand this, like, it gives you yes, you answer the question the same, but it gives you a more fundamental understanding of how logarithms work and what logarithms are. And so if you know this, it just makes things a little bit more concise and gives you a little bit more background understanding of what it is that you're doing, not just blindly following this formula that your teachers are giving you. Now on to part B. A square has sides of length 2 centimeters. The midpoints of the sides of the square are joined to form another square, like we see in the diagram, and this process is continued. So the first three squares in this process are shown below. That's what's in the diagram. And we want to find the sum of the perimeters of the squares if this process is continued indefinitely. Give your answer in the form a plus b root c centimeters, where a, b, and c are natural numbers. Okay, so whenever you see the word sum and indefinitely, so an infinite sum, whenever you see sum and indefinitely in the same sentence, really, in a Leaving Cert problem, you should be immediately thinking of a geometric sum, because those are the only infinite sums that we know how to deal with. So we're looking to find some geometric sequence hidden in the question. Okay, so we're adding the perimeters. Okay, so we're summing the perimeters. So let's say P1 plus P2 plus P3 plus so on and so forth. Okay, well, first of all, what is P1? Well, P1 is the 4 times the length of each side, so just 4 times 2 equals 8. And, well, what is P2? Now, we're looking for a geometric sequence, so something of the form a plus ar plus ar squared plus ar cubed plus and so on and so forth. So we're looking for a starting term, which we have just found, a. And now we're looking for a ratio r, the ratio between P1 and P2, which is the same ratio as between P2 and P3. So we want r. Okay, so well, let's try and calculate P2. So P2 is the sum, or let's do it in a different color. Well, it's 4 times this length. 4 times this length here. And what is this length? Well, they've split this square in half. So this is 1. And this is 1. So we have a right angle triangle with the 2 shorter sides of length 1. So whenever we have a right angle triangle, we should be immediately thinking a squared plus b squared equals c squared. And the hypotenuse, which is the length of the second square, is just c squared, or just, let's call this L squared equals 1 plus 1. So L equals the square root of 2. Okay, and P2 is equal to 4 times the square root of 2, because it's 4 times the length of each side. So P1 is equal to 8, and P2 equals 4 root 2. So, well, what's the ratio between them? So P2 over P1, our ratio is 4 root 2 over 2. Oh, sorry, over 8, which is just square root of 2 over 2. So that's the ratio between the perimeters of these squares. And so now we can fill in our geometric sequence. So 8 plus 8 times root 2 over 2 plus 8 times root 2 over 2 squared, plus, and so on and so forth, like this. And now we want to calculate the value of this sum, and we have our formula. The infinite sum of a geometric sequence is just the starting value over 1 minus the ratio. So if we fill that in our case, a equals 8, r equals square root 2 over 2, then we get the infinite sum of these terms is 8 over 1 minus the square root 2 over 2, which is 16 plus 8 root 2. So the trick here in this question is identifying that because we're looking at an infinite sum, we're going to eventually be looking at some geometric sequence, because that's the only infinite sum that we know how to work with. And then from there, it's just a matter of finding out what a is and finding out what r is, and then using the formula. The infinite sum is the starting value over 1 minus the ratio.